not be happening in a few years. Now, as part of that, I don't want to make it sound like it's doom and gloom. It's an interesting challenge to keep this going. But we have done amazing things, and this is partly to the hard work of many people, but also thanks to the contributions of many industry partners who have given us funding, who have given us funds, who have given us computational resources, who have given us human resources, engineers, teams of people who work with us. But I do want to stop and flag the three foundations at the top, the Helmsley Trust, the Alfred P. Sloan Foundation, and the Gordon and Betty Moore Foundation. These three foundations have poured over the last 5 or 6 years to the tune of about $7 million, give or take, into this project. This is real money. These are real resources. They believed in this when almost no one else thought that this should be the kind of work that got funded, and we're unbelievably grateful because without those resources, none of this really would have come to fruition. It would be impossible. We're at a scale where somebody's nice and weak and don't cut it at this point, and we needed real resources, and we're really grateful for that. So, with that said, I want to close on a bit of a personal note. As I mentioned, I was kind of joking about procrastination and hiding from my advice, but the reality is that when all of this started, I was in a pretty tough spot. I was not particularly happy with my dissertation topic. I was struggling, and for me, around disciplines. I ended up in applied math, doing research in neuroscience, and this is probably for me things that cut completely across the grain of what society makes. I just want to say that I also have it. I stay up late at night. I worry about this. We sort of need to embrace it and believe that together we can continue building cool things, even across the grain. I hope that this community will continue as it grows to be as welcoming and engaging as it can be creative in a technical sense, and so that we can continue building these tools for a better world, for a more open and for a more fair society. So I'm going to close by flagging that tomorrow we'll have a few more details about the fact that this is not, it's the inaugural conference, but it's only the inaugural conference. Next year, there will be a JupyterCon 2018. We'll be able to reveal some more details tomorrow about the location and dates and specifics, so we hope to see many of you and many of your colleagues coming next year. And I'm going to thank you. Thank you all for being here, for coming here, for making this possible. This is an absolute dream come true for me. Well, I shouldn't even say a dream because I think it would have been crazy for me to dream 15 years ago when I was planning on my PhD that this would be possible. So thank you very much. I hope to meet many of you and learn from you. And those of you who have made this possible, my most sincere thanks. It's really incredible to be here, and it is such an honor to be given the stage to speak to all of you here at the first JupyterCon. I look around at a lot of people in the halls, and it just reinforces how many people have worked so hard to make all this possible, and they've worked on it for, many people worked on it for over a decade. And I have a lot of thoughts around the technology dynamics that kind of bring us to this moment and that will lead us into the future, and about all the different possible features that are lay ahead. But I don't have a lot of time up here, so I'm going to focus basically on talking about one sort of common thing that I see between Jupyter and Anaconda, and what's made them successful, and also some of the challenges they face, I think that they'll face moving forward. So this conference, I think, is quite clear. It's sort of an inflection point, right? Or maybe it shows that we're undergoing an inflection where the technology that we've built is a small community, a relatively small community of contributors and innovators. That's really starting to go mainstream. And our community has had the good fortune of being descended from the Python, the SciPy communities, and that's led to, I think, a generally very welcoming and friendly to newcomers sort of atmosphere, right? Brett's quote about staying for the community, the Python community is absolutely wonderful. But it's important to keep in mind that many of the newcomers, most of the newcomers to our community have been interested
in the code and the technology. And when technologies cross from kind of that innovator early adopter into the mainstream of adoption, that user community that you get, the users are somewhat different. And the difference, I think, for like the early majority, late majority type of users is that the tools they're adopting, they're doing it to get their jobs done. Right? They're doing it to learn more, move up the career ladder. It's going to enable them to do their jobs better, but they go home at 5 p.m., they go home on the weekends, and they're going to watch TV, spend time with the kids. They're probably not, maybe many of them will, but they're mostly not going to be sitting there on GitHub at 9 p.m. on a Saturday night. And I don't mean that as a criticism, right? That's not a criticism. That's just, we shouldn't expect our users to, right? And so as a developer and innovator community, I think we need to recognize that meeting the needs of that kind of community, that user community, is going to take on a different kind of flavor. And in growing Anaconda, watching it go from, 1,000 downloads, over the course of a month to now we have millions and millions of downloads a month, I've definitely seen that transition happening in that user base. And I think that the Jupyter community is, you see the picture of the Berkeley class, is undergoing that same kind of transformation. And it does mean something different for all of us as a community, that kind of early innovator community that created it. And, I hit the wrong button, sorry. And that changing demographic, right, it's got real consequences for the technical community. Going from, playing gigs in a small band to playing stadiums, you have a very different kind of atmosphere that you would have it. And this related is actually the commercial adoption of Python in general, and the PyData, SciPy tools, and so the commercial adoption of Jupyter. And my company, Continuum Analytics, we've been at the crossroads of this since the very beginning, since the founding of the company, really. And so I've got a lot of opinions, more than will fit in a 10-minute time slot. So I encourage you guys to come to my talk at noon today, where I will go into much greater detail about this and have time for Q&A and really have a discussion around it, because I think it's one that, as a community, we need to have. But in this talk, I'm going to focus on one fundamentally important issue. And Fernando and I did not coordinate our keynotes, actually, as you can tell, because my issue is the same as his core issue, which is the one of sustainability. I think it says something at a meta level that the two of us didn't coordinate, but we're both focused and both interested in the topic of sustainability. Now, in an open source context, for a developer community of open source, devs, when we say sustainability, people now start nodding their heads. They understand, oh yeah, that's an issue, right? Because anyone who's made a popular open source library, they know that at some point, just putting up with, the issues and the triage and then responding to mail lists, it burns devs out, it creates tensions in the team, does all these things. And more critically, as software gets more and more popular, it passes this critical threshold where more of the important activity net, the most important activity is not the code itself, but it's things like documentation, workshops, tutorials. It's growing and adding new devs to the team. And so the communication and the knowledge artifacts become the more important thing, more so than the feature artifacts, actually. So now there's a lot of discussion about this, right? In recent years, we've had Heartbleed embarrassing the entire technical world. We've had the new PG project also being stored in funds. People were surprised when NumPy got its first funding, I think last year or maybe it was earlier this year. In the Python PyData world, with NumFocus, we've really been able to step up and address this over the last few years. It's still growing, but it's something that we've really been able to take some serious action about. And also, I think in the Python, PyData, SciPy world, we're very fortunate because the core of our work, it is actually in the critical path to business value, to analytical value for a lot of organizations. And so you do get funding from NSF, for all the foundations that Fernando mentioned. We get private funding from a lot of commercial partners like Two Sigma, Bloomberg. And so there's a lot of interest and money flowing into our ecosystem, which is really great. We still have to organize it, which is why NumFocus is so important in this regard. And additionally, because of our heritage coming from the scientific Python community and so many scientists having put their time into all this, it's important that they get recognition kind of in the academic ladder of merit, right? And that's the effort behind open access journals and the citation of source code. All these things are ways to help people who do this out of their love in their hearts actually be able to sustain that effort. But there is another aspect of sustainability that goes beyond what we typically think of, I think. And for me, that's the question of sustaining innovation. Right? We built something cool once, got lots of users, okay, that's pretty awesome. how do we keep doing cool things? How do we sustain that innovation and sustain that creativity? And that's actually really at the heart, I think, of what's continued to happen here with Jupyter. It's really also at the heart of the energy, the ethos, in the broader PyData, SciPy ecosystems. So when we talk about open source sustainability, and we think about it only from the software maintenance and the paying the starting devs angle, we're really answering the question of how. But if we want to address the why, for me, that answer has always been around sustaining innovation. And so Jupyter and Anaconda actually both suffer from a very similar misconception that I've seen out in the wild. And that misconception is that they're just tools. And I take the perspective, actually, that Jupyter and Anaconda are substrates for innovation, not just tools. Of course, we use them as tools, right? But they're actually bigger than that. And when you're substrate, you get misunderstood by everybody in different ways, right? So by people who are outsiders who are new to this stuff, right, they'll trivialize it. They'll say, well, the notebook thing, yeah, it's a web front end. Yeah, that's great, but, I got, Twitter, I got Medium, I have other web front ends I use. It's just a web front end. Or they look at Anaconda and they say, well, this is just a package manager. I've got Yum, I've got some other stuff. It's a package manager. And the other way is that if they look a little deeper, or if they don't look deeper, they may actually mistaken these substrate things for something much bigger than they are. They're mistaken for the whole mountain. Right? They'll think that Jupyter is pandas and Mount Paladin. Or they'll think that you can only do scikit-learn if you use Anaconda, right? And that kind of misunderstanding, you can sort of understand it and think, well, these people are new and all this stuff. But that's definitely a common misunderstanding. But insiders, people who are of the community, also can misunderstand substrate. And the misunderstanding there is basically, I think, tied to an underappreciation of how critically important it is to have common framework for the non-sexy stuff, for the baseline things, right? So the Jupyter format, the protocol, the comms protocol, not very sexy, critically important. Anaconda, the Conda package format, not that sexy, not machine learning, it's not feeding anyone a Go, but it's actually critically important as well. And so that critical aspect is that these frameworks, Jupyter and Anaconda, they establish lingua franca that actually allow a network of value to emerge between creators, innovators, users, everyone. That value network actually sustains a continuous stream of innovation. If you didn't have a bazaar, if you didn't have a marketplace where the people who can create and the people who want to consume those innovations can meet, you don't get this kind of positive creation of energy. And so, a metaphor I would use is that you have basically a scattered room full of step stools, but none of them take you very high. And if you actually have some kind of format, these baseline compatibility things, you can actually start stacking them on top of each other. You get a ladder. And that's a very, very important thing. And so the Jupyter Notebook is one of these things. I think Legos, Minecraft, they all have that same kind of texture. And so I think that for the platforms like Jupyter, Anaconda, these kind of infrastructure things, if you actually look broader, right, to Jupyter, to Conda Forge, the community starting to pitch in and add to these kinds of things. They're really the product of community, a movement, actually, that's driven by a belief in the empowerment of analytical thinkers. That's why people do this stuff. That's why they're stacking the step stools. And so the parting thought, I guess, is that when we look at the PyData and the SciPy ecosystems really growing in popularity, really beginning to adopt it universally, we're going to absolutely, there's no question, we're going to revolutionize data analytics and data exploration for many, many years to come. The potential is absolutely staggering, and it's going to take a lot of work. But as we're doing that work, we have to, as we participate in that community, it's absolutely critical for us to keep in mind the why, the purpose behind it. And for me, that purpose, that driving purpose, it's always been about ensuring that this open source value network, it remains open, and that it empowers innovation by a global community, for everyone on the planet. Thank you.
Rachel Thomas, and I am co-founder of FastAI and a researcher at USF Data Institute. We'll be talking about the course Practical Deep Learning for Coders. Briefly, my background, I studied math and computer science in undergrad and then did a PhD in pure math. I worked as a quant in energy trading, which is a lot of programming and working with data, and then actually O'Reilly Strata 2012 was part of what convinced me to switch into tech and become a data scientist. I was a data scientist and back-end engineer at Uber. I taught full-stack software development at an all-women coding academy, Hackbright, and I really love teaching, and I'll always return to it. And then a year and a half ago, Jeremy Howard and I founded FastAI with the goal of making deep learning more accessible and easier to use. I'm on Twitter at math_Rachel, and I blog about data science at fast.ai. I blog about diversity on Medium at RachelTHO. Yeah, so first, just the vocabulary. Deep learning refers to multi-layered neural networks. It's a very specific class of algorithms that's been given this ambiguous name that overloads two common words. It's a subset of machine learning, which is a subset of AI, and AI is a very broad field, but most of the advances that you hear about happening right now are all coming from deep learning, this one family of algorithms. So examples that you may have used in deep learning are Google Photos. Here I've entered the search term purple flowers, and it's showing me all the pictures I've taken of purple flowers. This is powered by deep learning. This is from Analytic, a medical startup that can outperform a panel of expert human radiologists in identifying lung cancer. And then last year, the Chinese tech giant Baidu announced that their deep learning system is better at English and Mandarin speech recognition than most people. So deep learning is being applied a ton right now to working with images and working with natural language. This is a slide that Jeff Dean of Google Brain shared last year, and it shows the growing use of deep learning at Google. So the x-axis here is the time, going from beginning of 2012 to mid-2016, and the y-axis is the number of unique projects at Google that were using deep learning. And so you can just see this exponential growth. And you list some of the areas that it was in, and it's deep learning is being applied to drug discovery, Gmail, images, natural language, maps, photos, robots. Just this huge variety. The reason I think this is significant is that Google tends to be ahead of most of us, and so we can expect other companies and other industries to follow this track of applying deep learning to more and more problems. So to get started, this is from the most popular textbook on deep learning. This is how we can gain intuition for back propagation through time. So what do you think? Is this intuitive to you? I have a PhD in math, and this is not intuitive to me, nor is it how I gain intuition. And this book, I should say, is a very useful resource, but I don't recommend it as the best place to get started. So a year ago, Jeremy Howard and I decided to create a course, Practical Deep Learning for Coders, that would have no advanced math prerequisites. And so this is very different from how other people were teaching deep learning. We partnered with the University of San Francisco's Data Institute. The course was offered one evening a week. Most people in the class are working full-time as data scientists or developers, and the only prerequisite was 1 year of coding experience. We've had a ton of success. One of our students got into the Google Brain residency, who had only been coding for a year. Many others got new job offers, won hackathons, launched companies, so it worked really well. We've released all the materials online for free at course.fast.ai, so you can check them out. But yeah, our motto is, if you can code, you can do deep learning. And it's all taught in Jupyter Notebooks, and I'll say a little bit more about our education philosophy in a moment. I wanted to tell you the stories of kind of a few of our students, and there's just a huge variety of projects that they've worked on. This is Xin-Xin Li of Akashi and Exceed. She's developing wearable devices for patients with Parkinson's disease. Typically, a doctor would kind of visually assess a patient walking down the hallway to assess how the disease is progressing. A wearable device is going to capture a lot more accurate and more precise data, and they're using deep learning to analyze it. This is a team of data scientists, Sarah Hooker's on the far right, that's looking with Delta Analytics, which pairs nonprofits with teams of data scientists. And this particular team is with Rainforest Connection, which puts recycled cell phones in endangered rainforests, streams audio, and then uses deep learning to identify chainsaw noises. And they have responders they can send out if someone's illegally cutting down the forest. There are a lot of interesting challenges. Apparently the frequency of chainsaws is the same as the frequency of mosquitoes, but they're having success with deep learning. These images were sent to me by Sushil Singla, a farm guide in India, and thousands of farmers commit suicide every year in India, in large part because they're taking very predatory loans from these thugs that harass them, and the farmers can't prove how much land they own or what type of crops they're growing. Sushil and his team are scraping publicly available satellite data